Hi students, today we're going to be graphing hyperbolas, and not the type you graphed last year. Last year you did the rational equations which make a hyperbola. That was the parent function, and they look like that, and you had a horizontal and a vertical asymptote. These are actually the conic sections instead of rationals, and here's how it's going to look. There's two different equations I need you to understand. The first one is where it starts with an x, and in both cases on hyperbolas, you're going to have one of them being subtracted. So here, if it starts with x minus the y squared, then the transverse is this axis that holds the foci or foci, the vertices, and the center. And so if you have one where the y is being subtracted, then it's going to be this side to side. It's going to be this horizontal transverse, okay? If it starts with the y and the x is negative, then your transverse, where your vertices and your foci and your center are going to be, will be vertical. So you're going to have this vertical transverse. Okay, now I want to erase those. I don't like those. Letters make it look all ugly. Okay, now let me show you this, and it's going to look kind of... now you can draw this if you want. It's not a very good drawing. I'd rather you wait until we graph both of them so you can kind of see what everything is and then label it. I think you'll remember it better. So we're going to look at the vertical transverse and the horizontal transverse. And as a matter of fact, if you look in your book, there'll be some things to remember. And one of them is, this is how you find the asymptotes for the B over A is these horizontal ones. And then A over B is for the vertical ones. But I don't do it this way. I mean, I'm going to show you how it works, but I just want to walk you through how I take care of these problems. So here's some things to remember of note. The covertices are on the transverse axis. The other axis, which we never talk about, is called the conjugate. The A, not A squared, but A, gives you the distance from the center to each vertex. The foci, or foci, are C units from the center, and you find that by A squared plus B squared plus, notice that, plus B squared is C squared. Standard equations will always equal 1, and asymptotes are more important than you think. So I'm going to just take you through the process of graphing each one. And all right, let's say that you have this. Now notice that your y is being subtracted, so this is going to look like this. It's going to be one of these deals on the horizontal. So first things first is I like to find the center. So my center here on the x, it's a 0. You find it just like you do the other conics, and the y is -2. So I go to 0 and -2, and I plot my center. Now I like to do my asymptotes next because they help me make my parabolas look better, and it shows you where things are going. So here's the deal: the asymptotes are always going to go through that center, and the slopes are always going to be opposites. And it's always going to be, for these, it's going to be B over A. So B over A, well, let's see. A is equal to 4, and B is equal to 3. So it's going to be 3/4. So I go up 3 over, let me write 3/4 so I don't get that wrong. It's 3 over 4. So it's going to be up 3 over 4. Hope I counted right. Up 3 over 4, and just keep doing that. And I like to do those with the highlighter. Okay, and now the other one is just going to be -3/4. Now, so this is my -3/4, this is my 3/4. They're not at right angles. They're just opposite slopes. But if someone wanted the equation for that, I can give it to them easily. This one is 3/4 x minus 2. There's my y-intercept. And this is -3/4 x minus 2. So I don't get into memorizing that formula. especially if all you have to do is draw them. Now, let's find the vertices. Now, remember, vertices, you find the A. My A is 4. And so it's going to be 4 units away to the right and to the left, because this is a horizontal, right? This is my horizontal transverse. So I'm going to go over 4, 1, 2, 3, 4. And I'm going to go right 4, 1, 2, 3, 4. And I have my vertices. Now here's why I like to do, what do you call these? The asymptotes. I like to do those because I know this graph is going to follow it. It's going to follow it and come increase. Oh, that looks like it should be more rounded. It's going to follow it, growing more and more and more close, infinitely close, but never quite touching. And on this one, it does the same thing. So there I've drawn my graphs without having to really plot points. And so those points are easy. It's -4, -2. And over here it's +4, -2. And now for my foci. Your foci is going to be C units from the center. Now to find C, remember you're going to have to do A squared plus B squared to find C squared. Well, A has already been squared for you, and B has already been squared for you, and you get 25. So if C squared is equal to 25, then C is equal to 5. So from the center, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And there is my foci. It's -5, -2. Well, I guess I should do it here. -5, -2. And +5, -2. So hopefully, if you write these steps down, it makes it easier. Center, asymptotes, vertices, foci. Foci. I keep saying it wrong. Okay, now let's do one where the x is being subtracted. So it is going to be one of these with a vertical transverse. So, and you're just going to find a cute little way to remember how to do that. So here we go. We're going to do the center first. Now the center, remember the x is over here, and -4, -3. So let's plot that. -4, 1, 2, 3, 4, 1, 2, 3. So I've done my center. Now let's find the asymptotes, because I'm going to come off the center with those. Now when it's in this form, it's A over B. And now my A, in this case, is 4, and my B is 1. I'm sorry, A squared, B squared. So that means my A is 2, almost messed up, and B is 1. All right, so that means 2 over 1 is the slope. So I'm going to count up 2 over 1, 2 over 1, and then from my center, and that will give me one of my asymptotes. And then do, now my center is right here. I should have done it in another color so I don't mess it up. Okay, that's my center. And then for the other direction, I'm going to go up 2 over 1, 2 over 1 the other direction, because that one is just -2. Okay, so I know that my parabolas are going to, or hyperbolas are going to fit in that slim little V right there. So let's find where the vertices are. Now remember, it's just A units, and here's my A, it's 2, from the center. But if it's, remember it's going up though, so it goes up 2 from the center, goes down 2 from the center, which would be -4, 1 for one of them, and -1, sorry, and then 3, 4, 5, -4, -5. This looks terrible. All right, and now I like to draw my hyperbolas because I know it's going to kind of hug this. And then this one, that first one doesn't that look terrible? All right. You're supposed to say, no, it looks great, Ms. Wilson. All right, so now all I have to find is my foci. Remember that C units away. So it's C squared is equal to A squared plus B squared. So in this case, that's 4 plus 1 which is 5. So c squared is 5. So c is the square root of 5, which is a little bit more than 2, right? So just kind of, it's a little bit more than 2, so it's going to be right there and right there. And as long as you identify them correctly. So since it's irrational, you can say on the x, it's -4 for both of them, right? But on the y, it's going to be, I just like to do it like this. You know how your original for your center is -3? Say -3 plus √5, -3 minus √5. And that is fine with me. Okay, so now that you've seen how all these different pieces work here, this would actually be a good time for you to draw your maps and do your notes. Okay, but make sure that you put the steps down and how to get them, how I use the A, how I use the C, how you use the slope. And matter of fact, I'm going to put that on the drawings. On this one, these things are A over B, and here they're B over A. I hope that helps. Okay, it's getting late. You guys take care.